in January 2002 with intense tropical cyclone Dina, which passed less than 80 kilometers from the island. So you can see here is the infrared, and here is the microwave brightness structure images, and here is an animation of PPI scan from the radar at 400 kilometer range. So you can see the classical structure. Two things are interesting to note is that the elliptical shape of the eye with some sort of a rotation, and the second one is the influence of the island, which produce perturbation in the rainfall field here. La Réunion is a volcanic, it's a relatively young geological volcanic island with an extinct volcano here and an active volcano here. The peak here is at more than 3,000 meters, which means that this island is some sort of a cone over the ocean, and it has an important effect on the low-level atmospheric circulation. Also, the topography in the center of the island blocks the radar beam. The Meteoforce radar is located here at the northern tip of the island. So it is only possible to obtain information within this region. Here you have the classical cyclone symbols indicate the position of the storm, official position of the storms, and the dots indicate the position of the storms, of the storm center, which has been deduced from the radar images. I used a method to deduce from this Doppler data information on the tangential and radio wind. I have no time to discuss this, but that's basically the same method that Wen Chao Li from NCAR uses with Taiwanese colleagues to analyze the data from Typhoon, which passed close to Taiwan. It can be observed with radar. So what we see here is that sorry. Okay. Is the tangential wind at 2 kilometer altitude. The radar is here. And these are three images at 1 hour 30 minutes apart. And you can see that the maximum here is above 60 meters per second. And more interestingly, what we found is that there is an azimuthal shift of this maximum. This fact, and also the fact that the trajectory change to the west, slightly to the west, has been analyzed as the effect of the island, which induced a perturbation of the flow. And so there is a change in the cyclonic circulation. Well, they turned in the wrong way in the southern hemisphere, sorry for that. And so this change induced a pressure perturbation here, which has changed the structure of the wind and the track. We analyzed the same storm with a numerical model, the non-hydrostatic numerical model with a 4 nested domain at 36, 12, 4, and 1 kilometers. The outer one with parameterized convection, the inner one with explicit convection. It was initialized with ECMWF analysis on January the 22nd at 0 UTC, and we use a vortex, a bogus vortex, because at this time ECMWF has an equivalent resolution of 40 kilometers, which was not enough to resolve the tropical cyclone structure. I will simply show you two interesting results, which are from the inner domain at 1 kilometer. This was at the time when the storm just arrived close to La Réunion Island. You just have the northern tip of the island is here on these images. These are 3 images at 10 minutes apart for simulated radar reflectivity, and here for the simulated relative vorticity should be at 1 kilometer level. Two things is that first thing is here you see that the eye wall, the eye is not even a circle or an elliptical shape. It is some sort of a rectangle which has a cyclonic circulation, which is rather original. And the second point is that if you see on vorticity, you see that there is a series of maxima that occur here all along the eye wall. And these maxima are accompanied with stronger winds at this level. The problem is to decide whether this structure, this interesting structure, are related to the storm dynamics, or do they result from interaction between the storm and the terrain. This question has not yet been solved, and it would be necessary to have another storm passing close to the island, but I think the inhabitants there would not like that. So the last part of my talk is about a project we would like to conduct next year. The name is SWICE, for Southwest Indian Ocean Tropical Cyclone Experiment. We do not yet have definite information on the finding, but should be coming in the next week or so. So this project is proposed by Météo France in La Réunion and by other laboratories in France. So in this region you have Madagascar here. This is the southeastern coast of Africa. La Réunion is here. And the red circle here is approximately the range that can be reached with the French aircraft, I will show you later. And so this will be the region where the experiment could be conducted. And the blue triangles are the operational radio sounding here. So you see there are not many radio sounding, and so one of the goals of the experiment would be to release drop zones close to storms, involving storms in this region, in order to have more information and to be able to have a more precise structure and evolution. So the scientific objectives are written here. TCU in structure. One thing important to notice is that there have never been any experiments or any in situ measurements in tropical cyclone in this region. So most of the forecast is made on information based on storm observed in the North Atlantic or in the Northwestern Pacific. So it would be interesting to get information, not in the inner part of the storm, because the aircraft will not fly within the storm, but at least in the outer part of the storm. And collecting new information with droplet sondes close to the storm will probably help to understand more clearly the relation between tropical storm track, evolution, structure, and even cyclogenesis in relation with the environmental condition here. And also we would like to use this experiment to validate new satellite observation, especially microphysical information on ice cloud over this region. The aircraft is Falcon 20 aircraft, will be based in La Réunion. Airspeed, maximum speed is 800 kilometers. It can fly 5 hours, and maximum altitude is 35,000 feet. So we will use this aircraft to release drop zones in a region of interest close to tropical cyclone, not within the storm. And it will also be equipped with 95 gigahertz 5-beam Doppler radar and microphysical probes with counters and images in order to deduce information on the characteristics of ice particles. And we plan also to have ozone and carbon monoxide and, if possible, nitrous oxide measurements. This will be indicator of troposphere, stratosphere, or mid-latitude tropics or continental ocean interactions, which are relatively important in this region. The satellite, new satellite information will come from a French-Indian satellite to be launched by India this year, probably in September. Don't ask me more.